Welcome to EDU World Space.
Here we're asked to identify the polydentate ligand present in a coordination complex and indicate the probable number of coordination positions that it occupies. So with this forced coordination complex, we have a couple of different ligands to look at. So we have NH3, and I'll draw the Lewis structures of each of these so that way we can identify what type of ligand it would be. So for NH3, and place that, this would be the hydrogen. Hydrogen, single bonds to each of them, and a single lone pair. So this is a monodentate ligand, so it is not going to be a polydentate ligand. Next we have this O-phen, which is an organic molecule orthophenethylene. And so we've got the structure of that. Looks like there. These are all coordinated, and then there are nitrogens here with lone pairs. So this has two different lone pair centers, two nitrogens, so this could be a bidentate ligand. So this O-phen is our bidentate ligand here. Next we have part B, so this complex, where we have Cr2O4, or an oxalate ion, where we have two carbons bound to 4 oxygens, 4, and they have 2 that are double bond and 2 that have single bonds. So we have differing numbers of lone pairs on each of those guys. And so this molecule overall has a charge of -2. Draw that in. Put that 2 minus. Okay, so because of this molecule is planar, and so you could imagine from one end to the other end, both sides binding, and so because of that, you're not going to have all 4 sites, electron-rich sites bound, and it's more likely going to be these 2 that have the negative charge that are contributing to that binding site, and so this is going to be a bidentate ligand. Water, H2O, so OH, it's 2 lone pairs, but you're never going to have these 2 sites being bound to the same molecule, and so this is going to be a monodentate ligand. Moving on to part C and D with this EDTA complex. So there's only one ligand in this complex, EDTA, and that's the ethylene diamine tetraacetate ion. And so I'll draw the Lewis structure of that. It's a pretty big one though, so I'm going to start in the center with 2 carbons, to a nitrogen, to a carbon, carbon, oxygen, and another oxygen up here. Got 2 hydrogens bound. And then it's a mirror image, so we've got another CH2, HH, CO, O, and then it's a mirror on this side, CH, H, C, O, O, double bond, C, H, C, O, O, many lone pairs. And then these guys have two. Okay, so this EDTA complex has a large number of electron-rich sites, and it's likely going to be a hexadentate ligand, and so we're just going to call it a polydentate ligand. For part D, we have this ethylene diamine, or EN, which is similar to this EDTA, where it is just a CH2, CH2, and H, where you have two sets, or two lone pair sets, two lone pairs on the nitrogen groups, and so this is a bidentate ligand.